Hello there, you're welcome once again to another session of learning. Today in our mathematics class, we'll be looking at LCM and HCF. LCM, which is lowest common multiples, and HCF, highest common factor. We are going to go on, we'll be looking into the details of this, but before we go on, let's quickly remind ourselves of what we learned previously. Learning is like a building, you keep laying bricks upon bricks until you achieve what you are desiring. Whatever we learn is like laying a foundation for future learning. Whatever we learn at every stage is a kind of creating a foundation for the next thing that is going to be learned, to have a foundation to stay on. I remember at the beginning of our learning, we talked about odd and even numbers, and we said that odd numbers are those numbers that you cannot pair. If you try to share them into two, you can never get two equal parts because there will always be a remainder. But even numbers, on the other hand, are those numbers that form pairs. When you share even numbers into two equal parts, you always get two equal parts. When you share even numbers into two parts, you always get two equal parts. Okay, so those are the basic things that we need to remember about odd and even numbers. Okay, let's also remind ourselves. We said that every other number, when we're counting normal numbers, every other number is either odd or even number. What does that mean? Like you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If 1 is an odd number, that means that the next number will be skipped, and then the following number will also be an odd number. Then you skip the very next number, and the following one will be an odd number, just like that. Every other number. And if 2 is an even number, that means 3, which is the next number, will be skipped, and then 4 will be an even number, 5 will be skipped, then 6 will be an even number, 7 will be skipped, and 8 will be an even number, just like that. So every other number is an even or an odd number. Now we said that since it was established that 1 is an odd number, every number that ends in 1 is an odd number. 3 is an odd number, every number that ends in 3 is an odd number. 5 is an odd number, every number that ends in 5 is an odd number. In the same vein, 2 is an odd number, and every number that ends in 2 is an even number. Just like that, every number that ends with an even number is an even number, and every number that ends with an odd number is an odd number. Okay, so today there is just one aspect we're going to add to this, which is the prime numbers. What are prime numbers? Now we have looked at even numbers, we have looked at odd numbers. So what are prime numbers? Prime numbers are those numbers that have only two numbers that can divide them. They have only two factors. Don't worry, you're going to find out what factors is shortly. Prime numbers are those numbers that have only two factors. That is, they have only two numbers that can divide them without any remainder. Now we have, for instance, 3. There is no other number that can divide 3 without a remainder except 1 and 3. Now, if you want to look at it, 2 actually is also a prime factor. 2 is a prime factor because if you take 2, no other number can divide 2 except 1 and 2. If you want to try 4, you can't say 4 is a prime factor. Why do I say that? 4 can divide 4, no remainder. 2 can divide 4, no remainder, and 1 can divide 4. So you have 3 numbers there that can divide 4 without a remainder. So 4 is not it's not a prime number. Let's try 5. If you look at 5, apart from 5 and 1, no other number can divide 5 without a remainder. So 5 also is a prime number. 7 also is a prime number. Shortly after now, you're going to find out why we are trying to look at prime numbers. Okay, so just take note for now that prime numbers are those numbers that have only two factors. That is, they are those numbers that only one and themselves can divide themselves. They have only two numbers that can divide them without a remainder. 3, only 1 and 3 can divide 3 without a remainder. 2, only 1 and 2 can divide 2 without a remainder. Only 1 and 5 can divide 5 without a remainder. So these numbers we are mentioning, 3, 2, 5, 7. 9 is not a prime number because 9 can divide 9, 3 can divide 9, and 1 can divide 9. Okay, so another prime number we have is 11 because only 1 and 11 can divide 11 without a remainder. Okay, so these are some examples of prime numbers. Now, when we want to look at LCM, lowest common multiple, and HCF, highest common factor, we definitely will make use of prime numbers, which in this case we'll be referring to as prime factors because they are trying to divide some numbers. Okay, we use them to find our lowest common multiple, LCM, or our highest common factor, which is HCF. We're going to find out how that plays out. But bear in mind, as we are moving on, that prime factors play a major role when we are trying to look for LCM and HCF. And some of the examples of prime factors we gave are 2, 3, 5, 7, 11. It goes on even 13, okay? Those are some examples of prime numbers. Okay, let's start with lowest common multiple. Now, what does lowest common multiple mean? What is the meaning of LCM, which is lowest common multiple? LCM refers to the smallest number that all original numbers can divide into without a remainder. The smallest number that a set, you can say all original numbers or a set of numbers can divide into without a remainder. Okay, so we're going to look at some examples, okay? The first one here would be the LCM of 8 and 12. So in this case, the set of numbers, this is the set of numbers, the set of 8 and 12. We're going to see the smallest number that these two numbers, that is 8 and 12, can divide into without a remainder. The smallest number that 8 and 12 can divide into without leaving a remainder. So let's see how we go about that. Remember, I shared about prime numbers with us. So you're going to see where it comes in here. Okay, so there are two methods we can use in finding our lowest common multiple. There are two methods we can use. We use the one we call prime factorization. There's the prime factorization method, and there is the long division method. The prime factorization method and the long division method. So those are the two methods that we can use to calculate our lowest common multiple, LCM. Okay, so let's take a look at how these two methods work. So let's look at the prime factorization method first. In the prime factorization method, what we need to do is we will have to break down each of these numbers into the prime numbers that will represent them. We need to break them down and represent them with the prime numbers that will multiply themselves to give us these numbers. For instance, 8. 8 is 2 times 2, 4 times 2, that's 8. Okay, so let's look at 12. How can we break 12 down? We know 12 also can be divided by 2, so 2 times 2 is 4 times 3. That gives us 12, right? Now, when you want to find the LCM of these two numbers, we have written this out. What you need to do now is you will take the highest factorization form of each of them and multiply them together. I hope it's not confused. I'll go over that again. To use prime factorization to find the LCM of these two numbers, 8 and 12, you first get their prime factorization, as in what are the prime numbers that multiply themselves to give you the number in question. For in this case, we have 8. So 8 will be 2 times 2, 4 times 2, 8. So 2 times 2 times 2 is the prime factorization of 8. Now let's go to 12. For 12, it is 2 times 2 will give us 4. 4 times 3 will give us 12. Right? Now there are other ways that we can break this thing down. If you want to start with 8, for instance, you can say, oh, 8 is 4 times 2, right? Now you know again that 4 can still be broken down further. So you say 4 is 2 times 2, and that is times another 2. It gives us 8. For 12, you can start, okay, if I break 12 into 2, I have 6 times 2, right? Now we know that 2 is a prime number. That means you can't break it down further. The only other number that can divide it is 1. So once you have a prime number, you stop there. But we know that 4 is not a prime number. 6 is not a prime number. So if you have a number that is not a prime number yet, you break it down further. So you ask yourself, what are the prime numbers that can multiply themselves to give us 6? We know that 6 is 2 times 3. So you have 2 times 3 times 2, right? That gives us 6. So for better organization, you organize the numbers 2 times 2 times 3. So that's how we arrive at this. Now what do we do next? The next thing is to take the highest power of each prime factorization. Now the highest power of this prime factorization is what? 2 times 2 times 2. This is the highest power of 2 as a prime factor. 2 in 3 places. Then if you look at 12, 12 is 2 times 2. That is 2 in 2 places, while the third number is a 3. Now, since we have already written 2 that is up to 3 times, we're not going to write this 2 again. Remember we said to get the LCM, we're going to use the highest power. This one has the highest power. This is 2 raised to power 3, while this one is 2 raised to power 2, which is higher. 2 raised to power 3 is higher. So we use the highest power of each prime factorization to determine the LCM. So for 8, the 8 has the highest prime factorization with 2. Okay, so we are taking the 2 from 8, which is 2 times 2 times 2. Then times, if you come to 12, we can't repeat this 2 anymore because it's not up to the 3 2's that we took. But there is a number in this 12 that is not reflected in 8. So the only thing we do is to pick that number. We are not picking these 2 because these 2 are already reflected in the 3 2's. But there is a number among the 12 prime factorization numbers that is not reflected in the 8 prime factorization. So we will take that extra number and add it to what we took from 8. So here we're going to have 2 times 2, 4 times 2, 8, 8 times 3, 24. So that means the lowest common multiple for 8 and 12 is 24. 24. Okay, I hope it's clear. We'll take another example, don't worry, using prime factorization. Then we'll now try a long method. I love it that we have two different strategies that we can use to solve this problem. Whichever one feels comfortable or convenient for you, you go ahead and use it. Okay, so we'll take another example. So the next example we're going to look at is finding the LCM of 12 and 18. This example 2, okay, finding the LCM of 12 and 18. So let's start with 12. Using the prime factorization method, 12 is same as 6 in 2 places, which is 6 times 2, right? Or we can do 2 times 6. 2 times 6, right? Now we know 2 is a prime number, so we can't break 2 down further. No other number can divide it except itself and 1. But 6 is not a prime number because we know there are 2 other numbers that can divide 6 apart from itself and 1. So let's try to break 6 down further. So this will give us 2 times, what numbers can we multiply to get 6? Or what number do we know that can break 6 down, that can divide 6 without a remainder? 2 can divide 6 because we said every number that ends in 6 is an even number. So let's use 2 again. So 2, how many times will 2 go into 6? It's 3 times. That's 2 times 3. So here we have 2 times 3, right? So our 12 is giving us 2 times 2, 4 times 3, 12. So we have 12. Now let's look for 18. Let's go to find 18. 18, if we break it into 2 parts, it gives us 2 times 9. 2 times 9 is 18. So we know 2 is a prime number. We can't break it down further. But 9 is not a prime number. We have established that earlier. That 9 is not a prime number. So we need to break 9 down further. So let's see. 2 times. What number can divide 9 apart from 9 and 1? What other numbers or number can divide 9 without a remainder? 3. 3 can divide 9. So 3 can go into 9 3 times. So 3 times 3 is 9. 3 times 3 will give us 9. So for 18, we have that 18 is equal to 2 times 3 times 3. Okay, I hope we are following. 12 is 2 times 2 times 3. 18 is 2 times 3. Okay, in case people are still confused or somebody is confused, 2 times 2 is 4. 4 times 3 is 12. That's how we have this. 18, 2 times 3 is what? 6. 6 times 3, 18. We are simply breaking down these numbers into their prime factors. We are breaking down this number into their prime factors, and we call this method prime factorization. Okay, so now that we have these numbers, we are going to use the highest power of each prime factorization to get our LCM, the highest power. Now let's look at this. Here we have 2 in 2 places, but here we have only we have 2 in just one place. So we're going to pick these 2. So we have 2 times 2. Now if you look at here, we have 1 3. But then when we come down here, we have only 1 2, but we have 2 3s. So 3 in 2 places is higher than 3 in 1 place. So we will not use this 1 3, rather we will come here and use the 2 3s. And if you see here, we have 1 2. We won't use it because we have 2 2s here. So we always go for the higher number and we pick it wherever we find it. Okay, we go for the highest power of each factorization, and that's what we pick and use. So here we have 2, we pick 2 times 2, and then down here in 18 we have 3 times 3, we pick that one as well. Okay, so the other numbers that are mere repetition, which are lower in value or which are lower in power, we don't use them. We only use the ones with the highest power of prime factorization. So here we have 2 times 2 times 3 times 3. So 2 times 2 is 4. 4 times 3 is 12. And 12 times 3 is... 12 times 3 is what? 36. Okay? So 12 times 3 is 36. That means the smallest number that 12 and 18 can divide without a remainder is 36. That's what we have here, 36. Therefore, LCM of 12 and 18 equal to 36. I hope it's clear. This is prime factorization method. Now let's look at the long division method. Let's look at the long division method. Let's still use the same numbers. Let's use the same numbers, 12 and 18. LCM of 12 and 18. Now, please, let's pay attention. So to get the LCM of these two numbers, what you do is you write 12 and you write 18. Okay, you roll like that. Okay, please take notes. This is how you write out the numbers and you draw this out. Now you're going to start with the smallest prime number that can divide these two numbers. The smallest prime number that can divide these two numbers. Mind you, even if the prime number that you arrive at can divide or can't divide the other, don't bother. Just do your division for that number and bring the other number down until you find something that can divide it out. So here we have 12, we have 18. We know 12 is an even number and 18 is an even number. That means 2 as a prime number can divide 2 of them. So 2 divide 12 will give us 6. 2 divide 18, it will give us 9. Okay? So now we have two new numbers, 6 and 9. We know 6 is an even number, but 9 is an odd number. So what prime number do we think we should use next? We still use 2 because 2 can divide 6. Okay? It's when you have finished, you have exhausted the smallest prime number that you can move to the next one, the higher one. You won't just say because 3 can divide 6 and can divide 9, you move to 3 here. No. There's still a number here that can be divided by the smallest prime number, which is 2. So you go ahead and still use 2. So we use 2 to divide 6, we have 3. 2 to divide 9, there will be a remainder, so we repeat our 9. We are not going to touch 9 or break it down because there will be a remainder, we don't need that. So we write it out like that. Okay? Now we have two numbers, 3 and 9. We know that 2 cannot divide 3 without a remainder. Neither can 2 divide 9 without a remainder. Why? Because 3 and 9 are odd numbers. Why 2 is an even number. So we try the next higher prime number. And the next higher prime number to 2 is what? 3. 3 is the next higher prime number. So 3 divide 3, 1. 3 divide 9, 3. We are not done dividing because there's still a number to divide, and that number is 3. So 3 will come again. So 3 divide 3, 1. 3 divide 1, we just write down 1. It's not dividing anymore. And 3 divide 3, we have 1. At the end of the day, you're going to multiply all these prime numbers that you used in dividing the two numbers. Okay, let's go over this again. So to find the LCM of 12 and 18, write them out like this, like in a tabular form. You start dividing them. You start from the least possible prime number. Okay, from the smallest. Here, we see that 12 and 18 are even numbers. So we start with 2, because 2 is the smallest prime number. So 2 divides 12, it gives 6. It divides 18, it gives 9. Now 2 divides 6, you see 6, you see 9. Somebody will say 3 can divide 9 and 6, we know. But as long as there's a number that can still be divided by 2, go ahead and use your 2. So 2 divides 6, 3, 2 divides 9, no. We repeat 9 because there will be a remainder. so don't touch it. The next thing is you look at the new numbers 3 and 9. 2 can't divide these two numbers anymore, so we use 3. 3 divide 3, 1. 3 divide 9, and that's where we arrive. That's how we arrive at this. Now what do we do next? You have to copy out these prime numbers, you multiply them. So you have 2 times 2 times 3 times 3. So your LCM is equal to 2 times 2 is 4. 4 times 3 is 12. 12 times 3 is 36. So you see that we got exactly the same answer as the one we got when we used the prime factorization. Now, like I mentioned, whatever method works for you, whatever method you feel is best for you, please go ahead and use it. That's the essence of trying different strategies so that you can find what works for you. We're going to use the method of long division to try and work on the LCM of 8 and 12. Okay, so here let's go ahead. We have 8 and 12, they are both even numbers. They are both even numbers. So we try 2, we start with 2 because definitely 2 can divide them. So here we have 4, here we have 6. Both are even numbers again, so we use 2 divide 2, 4, 2 divide 6, 3. Now we have 2 and 3, so 2 will still be used. 2 divides 2, 1, 2 divide 3, no, there will be a remainder, so we repeat 3. And then lastly, we use 3, 1 here, 1 here. That's the end. So what do we have here? We have 2, remember, 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. So we have 2 times 2 is 4, times 2 is 8, times 3 is 24. You remember when we did use the prime factorization method to find the LCM of these two numbers, 8 and 12, we got 24. Okay, so that's what we still got. So the next one that we're going to look at now is HCF, which is highest common factor. What is highest common factor? Highest common factor simply refers to the largest number or the highest prime number that can divide a set of numbers. Remember, for lowest common multiples, we said it is that number that a set of numbers can divide through without leaving a remainder. The smallest number that a set of numbers can divide through without leaving a remainder. But then in the case of highest common factor, it is that largest factor, that largest number that can divide a set of numbers without a remainder. The largest number that can divide a set of numbers without remainder. Okay, so we're going to look at, there are also two methods we can use for this, the prime factorization method and the long division method. But then there is slight variation in how we get our final answers. So let's start with the prime factorization method. So here we have 6, just like we did in the case of a lowest common multiple. 6 is what? 2 times 3. 2 times 3 is 6. And then we come to 15. Now let's try and break 15 down. What numbers do we know that can multiply themselves to give us 15? 15 is an odd number, it's not an even number. Okay, so 2 is out of the question. Okay, so let's think of 3. If we divide 15 by 3, can we get something without a remainder? Yes, we get 5. So that means that 15 is 3 in 5 places, 3 times 5. Okay. Now remember, in the case of a lowest common multiple, we said you use the highest power of each prime factorization. In that case, if it was lowest common multiple we're looking for, would have picked 2, would have picked 1 3, and would have picked 1 5. So it would have been 2 times 3 times 5, which is 30. Okay. But in the case of HCF, highest common factor, we only look for that prime number that is common to the two of them, or the prime factor rather, that is common to the two sets of numbers. So we look at 6, we look at the prime factors of 6, we have 2 and 3. Look at the prime factors of 15, we have 3 and 5. So which prime factor is common to the two of them? Is 3. You have 3 in 6, you have 3 in 15. So that means 3 is the highest common factor of 6 and 15. That means 3 is the biggest number, the largest number, the highest factor that can divide 6 and 15 without a remainder. Okay? We still use the method of prime factorization like we did in LCM. Remember, in LCM we use the highest power of each. We must represent each number when we are talking of LCM. If it was LCM, we would have picked these 2 because there is no other 2 anywhere that is larger. We would have picked 1 3 because here is 1, here is 1, so we must pick 1. And then we would have picked 5. So we would have had 2 times 3 times 5 as our LCM, which will give us 30. Meaning that 30 is the smallest number that 6 and 15 can divide without a remainder. But in the case of HCF, highest common factor, you look at the prime factors of the two numbers, or if there are 3 numbers, it doesn't matter how many numbers, just look through their prime factors. Whatever is common to all of them, that's what you pick out. If it's just one number that's common to all of them, pick out that number. If there are more, pick them out, multiply, and get your final answer. So in this case, 6 is 2 times 3, 15 is 3 times 5. So we see that only 3 is common to the two numbers. So it's only 3 that's common. That means 3 is the highest common factor of 6 and 15. The next example we are looking at is the HCF of 12 and 18, looking for the highest common factor of 12 and 18. So for 12, we have, we know that 12 is 2 times 6, right? But we can't stop at 6 because 6 is not a prime number. So we go further. So that gives us 2 times. What are the prime factors that will multiply themselves to give us 6? Is 2 times 3, 6. So 12 is ultimately 2 times 2, 4 times 3, 12. And the next one is 18. We know that 18 is 2 times 9, right? But 9 again is not an odd number, so we try to break it down. Sorry, it's not a prime number. We try to break it down to its prime factors. So the prime factors of 9 are 3 times 3, because 3 times 3 gives us 9. So we have our numbers spread out. But remember, we said that in the case of HCF, you know, when we use these numbers for LCM, we pick 2 times 2 up here, and we pick 3 times 3 down here. We multiplied everything. We got 36. But in the case of HCF, you will only pick the prime factors that are common to the two numbers. You pick what is common to the two numbers. So if we look at these numbers, we see that we have 2 up here, and we also have 2 down here, right? The next number here, we have 2, we have 3. They are not the same, but we also have 3 and 3 here. So we have 2 and we have 3 common to the two numbers. So the HCF would be 2 times 3. Mind you, the two numbers, as they are common to each other, you pick them only once. Since you have 2 up, have 2 down, you just pick that 1, 2, not 2, 2, no. And since you have 3 up, 3 down, you are picking 1, 3. So here we have 2 times 3 as the HCF, which is equal to 6. That means the HCF of 12 and 18 is equal to, is equal to 6. The HCF of 12 and 18 is equal to 6. Pick what is common and just write it out once. You have 2 here, you circle, we pick 1. 3, 3, pick 1. Okay, so 2 times 3, it gives us 6. That's our highest common factor for 12 and 18. Now we're going to use the division method for these numbers as well, and yeah, that's what we're going to call it a day. Let's use the division method and see what we'll come up with. In using the division method, we're also going to try and go like the way we did for LCM, though we have some slight difference here. Okay, but from the arrangement you can see there they have similarities. So you write out the numbers like this, and then you start with the lowest. Like in the LCM, in the case of the LCM, we start with the lowest prime factor, okay, until you divide out everything. But in the case of HCF, that is not the case. That is not the case. What happens is you have to look for the prime factor that can divide the two numbers. Whenever you get to the point that you cannot find a prime factor that will divide the two numbers, you're going to stop there. You're going to stop there. Okay, so let's say 12 is an even number, 18 is also an even number. So do we think 2 can divide these two numbers? Yes, we said that 2 can divide any number that is an even number. And any number that ends in 2 is an even number. Any number that ends in 8 is an even number. So 2 can go. 2 divides 12, 6. 2 divides 8, 9. Okay, so we have 6 here and we have 9. Let's look at this. 2 can divide 6, but 2 cannot divide 9. So 2 is out of the question. What other number can divide 6? What other prime factor can divide 6? Let's check 3. Can 3 divide 6? Yes, it can. And can 3 divide 9? Yes, it can. So that means we go ahead and use 3. Mind you, if it was LCM, you will still use 2. Okay? Until you get to a point you can't use 2 anymore. But here, we can't use 2 because 2 cannot divide the two numbers. So we need to look for that prime factor that can divide the two numbers and use it. If we cannot find, we will stop there. That's the end of the problem solving. Okay? So, but here we found that 3 can divide 6 and 3 can divide 9. So we go ahead and use 3. Okay? So 3 divides 6 is 2 times. 3 divides 9 is 3 times. Now we have 2 and 3. If we use 2 now, 2 can divide 2, but it can't divide 3. If we use 3, 3 cannot divide 2, it can divide 3. So that means we have come to the end of the road. There is no prime factor that can divide these two numbers, that we will run into a problem of remainder. Okay, so we're going to stop here and we will take the multiplication of these two prime factors. That will give us our answer. So we have 2 times 3, which is 6. That means the HCF of 12 and 18 is what? Is 6. The HCF of 12 and 18 is 6. So we see this is exactly the same answer we got when we used the prime factorization method. So whether you use the prime factorization method or you use this long division, as long as you understand what you are looking out for, you will definitely get the same answer. So for prime factorization, you just break the number down into the prime factorization, into the prime numbers that can multiply themselves to give you the number. And then what you do is you use the highest power of each prime factorization to get your multiplication. And when you do that, you multiply what you have and you get your final answer. Always remember that in lowest common multiple, you use the highest power of each prime factorization. Any any of the numbers that has the highest prime factorization, pick that one. Not everything you are picking, pick the highest one. Go to the next number, whatever it has that is more than the first one, pick those ones. So multiply everything together, you get your answer. But in the case of HCF, what you do when you are using prime factorization is you look out for the prime factor that is common to the two numbers. What prime factor is here that is also here? What prime factor is here? So any prime factor that is common to the two of them, that's what you pick. If it's one, pick one. If it's more than one, pick them. And then you multiply those numbers to get your answer. Okay, so for long division, when you're using long division method, in the case of LCM, you will keep dividing until there is nothing left to divide. And at the end of the day, you're going to multiply all the prime factors that you used in dividing to get your answer. But in the case of HCF, using long division, you only divide for as long as you have a common prime factor that can divide the two numbers or the numbers that you have to divide, because it could be more than two, sometimes it could be three, it could be four. So as long as you have a prime factor that can divide those numbers, you go ahead. But once you run out of numbers that can divide all of them without a remainder, you have to stop. So you can see that here now we still have 2 and 3 as numbers, but we have stopped. Why? Because there is no prime factor that can divide 2 and also divide 3 without a remainder. So that's the difference between LCM and HCF. So for the two, you can use prime factorization or long division, but you just have to know how the two strategies apply for the two of them, HCF and LCM. Quite an interesting topic. If we have the time, we could do more exploration, but for now, that's where we're calling it today. Okay, we hope to see you again next week. Stay blessed and stay safe.